Hi there. I'm back with another video today on OpenAI's Codex application. I started using this on the weekend to continue on with my retro video game project where I was creating a implementation of Avalon Hill's Stocks and Bonds, which is a old board game from, I think it's the 1960s was when it originally came out. But it's a very simple sort of a spreadsheety type of game where you've got a number of stocks and a municipal bond that players can buy and sell on a yearly basis, and there's a market mechanic that each stock can go up and down. They pay out, some of them pay out dividends, and then there's also margin you can buy on. You so essentially buy and take a loan out to pay for stocks, that sort of thing. And I started doing this development work using Claude's projects, but I ran out of tokens last week, and I'm still waiting for a refresh. So in order to keep my momentum going, I decided to take another stab at using ChatGPT. The last time I used ChatGPT for this project work, or at least tried to kick the tires on it, I was using the command line interface in VS Code, and I really did not get satisfactory results from it. So I kind of put that aside and just focused on the Claude project stuff because that was what was working for me. Because I was kind of forced into it, I decided to download OpenAI's Codex, which is a desktop application for Windows and for Mac right now. I think they are planning a Linux version, but those are the only two platforms that they currently support. And it's not too dissimilar from their online chat interface, with the exception that you're working off of a local folder. So the advantage of this is that, at least over the Claude projects interface, is that each project that you have inside of your Codex application has access to the entire repository, and I mostly got these going from a one-to-one of the folder I'm in is a GitHub repository, and so it has access to everything. But the thing that I found, at least I had tried to do some agent instructions in VS Code, and maybe if I took what I've done now and hooked that up using the VS Code command line interface, I'd get better results than I did before. But I did get this working pretty well. I still think that the Claude coding model is a better model overall. It produces less unpredictable results. The ChatGPT model still has a tendency to do things that you didn't ask it to do, but there are ways to restrict that, and I'll go into detail for this specific project, just kind of show you how I did it for this one. It'll differ depending on the type of work that you're doing, but let me just kind of walk over the interface to start. So on your left here, you've got these different, well, they call them threads, but if you click on the button here, you can add a new project and choose a folder on your local computer. So I've got one here, which is my retro MAME developer. This is the one that I worked in primarily. And you can see I've got a number of, it's going to show me the rest. Yeah, so here's all the conversations that I used to sort of do the majority of the work. There's a couple over here at the very end. Something that I did today is I split. This is a larger project called Retro MAME Developer that I used to kind of do. It's like the parent that holds some build scripts and it has like a Nitro OS 9 examples folder project that's got a bunch of sort of sample code. As I was developing the Stocks and Bonds application, I had a subfolder called Stocks and Bonds where all the work was sort of living inside. And so I've split that off to the Stocks and Bonds thing, but most of the conversation is down here. Let me kind of show you how I started. Because I found the nice thing about models is you can pretty much instruct them to do the work for you if you're clear on your instructions. And if you aren't clear on how to do it, you can ask it and it will usually give you a pretty good response. So here again, I was coming in blind, not familiar with the Codex interface or how you're supposed to set up agents files to define the instructions that you want to follow. So I just said, can you help me set up this project so that I can instruct you how to develop Basic 09 code for the retro Nitro OS 9 OS on the Tandy Coco 3. The instructions are in the stocks and bonds doc/agents project subfolder. So in that subfolder on my retro repository at the time, I had 3 markdown documents. One which was the agent instructions that I covered on a previous video in Claude's projects for the actual Basic 09 development agent. I had a separate one that was specifically the Nitro OS 9 technical reference agent, so they had access to the technical documentation for Nitro OS 9. And again, the reason why I had to split them is because Claude, I would run out of overall context if I tried to add it all into one single project, so I had to split my work into 3 projects. The third one was the Nitro OS 9. You can get access to the assembly language code. It's available on a GitHub, public GitHub project. So I had a separate agent with separate instructions that would be able to go there and get into that. But the technical agent and the Basic OS 9 agent were the 2 primary ones. So anyway, I was just saying, here's the instructions that I want you to follow. So it set up a AGENTS.md document at the root of I think it did it both at the root of the retro MAME developer, and then it put a separate one in the stocks and bonds. And it was updating those at my instructions to kind of keep it so that it would both point to those other documentation, the other documentation that I provided to the project, so it was using that as a reference. The instructions to do that were stored in those agents.md files. And so those are definitely, it's very important when you are using Codex to make sure you are building an agents.md file that clearly outlines what you expect the model to do and the behaviors that you want to follow, as well as the references that you want it to look at when you're asking it to do different tasks. Then I started on, okay, here's where we are based on this planning document in the design folder, and then we started kind of working through there. I won't go into the full details of this, but basically I already had some pre-existing sort of design phase documents. I was in a where I was trying to the problem that I got stuck on when I lost ability to do Claude work was because this hardware is so limited in its abilities, especially compared to modern computing. Effectively, the way the Coco 3 works, it's a late era replacement for what were the Coco 1 and Coco 2, which from a hardware perspective are pretty much indistinguishable. The main differences were that the Coco 2 had a better keyboard and by default had more, on average, memory installed than the Coco 1, but they both could be upgraded to a maximum of 64K. The Coco 3 has extra chips and extra hardware in it that allows you to essentially do what's called paging, and to have so it allows for a lot larger memory size, but you still are only working within 64K add a chunk for any given process, at least within Nitro OS 9, which is the operating system that's sort of built on top of it. So because my code base at the point had grown well beyond what would fit inside one 64K block of memory, I was trying to find a solution to be able to basically to carve off chunks of the code into separate processes and then be able to send information back and forth. It's easy to send information from the parent that's spawning off the child to the child on startup, but going the other way was the hard problem. And I first tried doing something where I was writing through the pipe with a 256 byte response that was kind of built in, but the only pipes you could override were standard in, standard out, and standard error, which is an error out, and I needed those for the actual application, so that ended up being something I couldn't do. Then I tried to I can't remember what the next thing I was trying to do, but anyway, I eventually landed on I'm going to have to do it through a file-based structure. So I was working on doing that sort of re-engineering with this phase child design at the point I think I switched over to ChatGPT, and so I was kind of working on that. I've been slowly breaking up my code into different phases and trying to figure out how much code I could fit into each individual process and how I needed to kind of break down my phases. Long story short, within where are we? So this is Wednesday, so it was Saturday, Sunday, Monday, Tuesday. By Tuesday at least, but certainly within 5 days, I've gone from having a lot of different procedures that I know. I built harness tests, so I knew each of the procedures worked individually, but I didn't have an end-to-end thing working. To today, I have what is effectively a 1.0 release almost completely ready. And it's all working. Everything I've done really thorough. If there are bugs, they're pretty minor now. You can do all of the functionalities in place, including the optional rules that I don't think I had even fully baked on Saturday. Everything got built. And again, it was all through working with this process of modifying, in particular, these agents files. Let me open up my agents here so I can kind of show you. So today, like I said, I split off my subfolder into its own GitHub repo, and I'll put a link to it in the description if you want to take a look at this yourself. So now there's just a single agents file, and the last thing I did today was do a review of my original instruction documents, of which there are several. There's from ChatGPT's perspective, the root is this agents document. This is the one that tells it what to do and where to go elsewhere in the repository for other information in order to sort of keep everything going. The next section that it has is under the agents folder. I don't think these have changed all that much, but under the reference section, I've got best practices and error handling. So this best practices doc is one that I'd had from previous work with Gemini. Actually, is where I started developing this best practices document and the error handling document. And this has evolved as I've kind of gone through here. But it kind of tells, again, because I chose a obscure variant of BASIC for an obsolete operating system on a 30-year-old computer, there's very little that ChatGPT brings to the table as far as what it understands of how to develop for this platform, and in fact has far more and this is true with Claude as well, it has far more predilections to create bad basic 09 code because it's been trained a lot on more modern basic flavors like Visual Basic, which has all sorts of functionality that is not available in this particular language. So we've got our statement and control flow. So these are all the reserved words that you are not allowed to use for variable names or type attributes inside of Basic 09. Most of these are functions that or logic statements. So they're all part of the basic language essentially. These are the data types, so the only types of data that you have available to you. Your file access parameters, so these are the flags for how you access files, whether it's a directory where you want to do exec on the file, or you want to read it or write it or update it. And then there's rules based around different sections. So code structure. We want to divide your programming into multiple procedures, each with a specific function. Limit source changes to the tasks at hand. So again, another thing that I find, if you aren't clear that you want to do surgical updates, and that's a good term if you're finding that you give it a block of code and it rewrites a bunch of stuff that you didn't want to touch, or it pairs out comments that are supposed to stay there. this is where you want instructions something like this, like I said, or the term surgical edits are often defined as a good short term for much the same thing. But yeah, limit your source changes to the task at hand. So they should be targeted to just solving the assigned task and leave the rest of the code unchanged. Then there's some language specific ones like colon equals and equals can both be used. For assignment, I wanted to adopt a colon equals as an assignment and equals as a comparison, just to help visually make those two operations distinct when you're looking at the source code. I don't think I'll go through all of this, but you can see we've got all sorts of different, some of it's language based, some of it's more about how to use line numbering. There's some line numbering in Basic 09, but it's something you want to use pretty sparingly, and I try and give specific examples of when you might want to use it and mostly to avoid it. Again, things you can only do one program statement per line. You can concatenate shorter statements, but generally for readability, it's better to have one statement on a line. And you also can't split a program statement across multiple lines. This is one thing that if I didn't have this instruction, it would definitely do, because there's lots of languages that allow you to have and use either indentation or line terminators or statement terminators that kind of help it understand this is, even though this is statements appearing on 3 lines, it's all the same statement. That's not available in Basic 09. And then examples for commenting. That's why I've got inconsistent formatting on my spacing. I'll fix that later. Okay, but yeah, then there's just some tables. I'm using Markdown because I like one that it's kind of that mix of simple enough that it's easy to read, easy to write, but also you've got some complexity like tables you can do to sort of organize things. So this is a table documentation. If I just switch this over to a preview, you can see it becomes a nice visible table when you look at it in that preview mode. And then, yeah, just a lot of different sort of specifics about how to write the language. Like I said, I started with something that has been evolving as I've been going through this process. And like I said, at the very end of this, one of the last things that I've just done is revisited this based on my entire code structure, to not just to look for things that are no longer true based on the code that actually ended up being built as part of the application, as well as flag things in the application that aren't being addressed in here. So that whole revision has been very helpful. And then there's also the error handling, which is specifically dealing with the task of dealing with error handling. Okay, so coming back to this, I did do a bit of a summarizing here. Again, why do it myself when I can get the model to do it for me and then just give my feedback? I wanted to have some notes for best practices when working with a model to write code and develop an application, and that's what I'm going to finish this video off with here. So it gave me my first draft, and then I said I wanted to add some more comments in here, so it gave me some comments, and then I said I wanted to do some more clarification on some of the things that it said. Here's where we got to with the unified version, and this is the one that's specifically for the retro project, and that was start from authoritative project assets. So begin with existing source templates, reference implementations, architecture notes, coding standards, workflow instructions, and established module patterns. Treat these as the baseline contract for structure, naming interface, error handling, state transitions, and review expectations. Do not let the model invent patterns when working. Project-specific ones already exist. Generate from known good patterns, not from scratch. So use template source and prior working code as the base for new code generation. Have the model adapt an established pattern to the new requirement rather than freehand a novel structure. This keeps new work consistent with the application and reduces variance across features. Again, this is a lot of the time to get a successful workflow going with a model. It's very important that you spend a lot of time both at the beginning of the project as well as you're working through it, of both creating clear instructions and examples of what it is that we're building, how I want you to build, and the expectations of the behavior that I want you to do and what I don't want you to do. And that's where you've got that good combination of source templates, reference implementations, architecture notes, coding standards, workflow instructions, and established module patterns. So using an iterative generation loop, start from templates and instructions, generate or revise code for the current requirement. Validate the result against the task, active task, existing coding patterns and project constraints. Feed corrections and feed findings back into the next iteration. So that's, again, early on, this part will be very important, that it's not just about making sure that it does what you want it to do, but QAing the code. You have to spend a lot of time early on doing code reviews and making sure that that the code that it presents isn't just satisfying the request, but that it's doing it in a way that's consistent and maintainable going forward, so that even if the code that it writes does what you want to do, but it doesn't match the style that you've already sort of set as your precondition, you need to go back and look at your instructions to find out, and this is where you can even ask the model, why I've given you these specific instructions and yet this is what you've given me. Why did you do that? Often it'll give you some hints. It may not be able to explicitly answer, but often it can. And even if it can't give you an explicit description of why it did it, it gives you hints so that you can kind of dig into the instructions and modify them so that going forward it keeps following. Revisit templates and documentation at the right frequency. Again, early on in the project or while a workflow is still unstable, you want to revisit your templates and documentation more often. If issues keep appearing, you want to use those source materials to recalibrate the model's output and reestablish the correct pattern. Good checkpoints include completion of a feature slice, introduction of a new workflow, preparation for integration, or final review. So if repeated defects or inconsistencies reappear, increase the review cadence again until stability returns. Again, extremely important that you focus on this, especially early on. As soon as things start to drift away from your expectations, you need to dig in with the model on trying to understand why it's giving you something that you didn't ask it to do, either whether it's changing something you didn't ask it to change, or it's giving you a result that, while maybe technically matches what you asked for, isn't a reflection of your expectations. Often that means you need to go back and review your instructions and your source that you're providing it, so that it cleans up those ambiguities in your initial starting, your kernel starting data. Use test harnesses to validate workflows and functionality. So you want to use focused test harnesses to validate not only bug fixes, but also proposed workflows, feature behavior, integration boundaries, and application state transitions. A harness should provide that the intended behavior works under the target scenario, not merely that the code compiles or appears plausible. Again, it's one of those things that developers often give short shrift to because it can be fairly tedious. But as long as you've got good templating for what good test harnesses look like, you can get the model to often generate the harness for you, as long as you're clear in your description of the problem you want to solve, as well as the expectations and a clear vocalization of what the edge cases might be. Keep harnesses narrow and purpose-built so that they test the behavior under investigation without unnecessary structural change. So again, it's all of the skills that you should be developing as a good developer is data that you want to feed into the model to make sure that it's following the instructions that so that it's producing the quality output that you're expecting, that you would expect from a human developer reporting to you as well. Preserve the intended scenario during validation. So when validating a new workflow or diagnosing a defect, keep the scenario stable unless the scenario itself is what is being redesigned. Preserve execution order, prompts, inputs, pauses, interaction model, and acceptance conditions unless a change to those items is explicitly part of the task. If you modify a harness, do so minimally and state what must remain unchanged. Prefer small, reviewable increments. Make narrowly scoped changes tied to a specific requirement, defect, or hypothesis. Validate each increment before widening the scope. Avoid bundling cleanup, unrelated refactors, or speculative improvements into the same change. So again, it's very easy to get the model to produce a whole lot of content all at once. And you will get much more success out of the results if you're doing a lot of smaller incremental changes than one big prompt to get a whole big pile of changes. I have found that you can, if this change that you want to make is the same small change but across a large base of the code, like for instance, one of the last cleanups I did was my error handling had requested that you always put error handling in regardless of the procedure's logic, and we did a revision to the base practices that said if a procedure is basically just doing simple logic like if else and there's nothing in there that's like an IO or system call, that sort of thing, it doesn't really need an exception handler at the bottom. And so after we revised that documentation, I gave it a request to go and search through the entire code base and identify procedures that might meet this condition. Then it changed all of them at once. But because it's all the same kind of change, I could just go and look at the individual change inside of the GitHub desktop to see, or the source code, either way, and just verify that, yeah, that procedure's good, that procedure's good, that procedure's good. So a whole lot of the same type of change isn't as dangerous as doing 50 different changes all within the same thing. It's much more likely to be a satisfactory result if you break it down into individual types of changes. Separate observed facts from hypotheses. Distinguish clearly between what was observed in code, test output, or user reports and what is only inferred. Do not claim root cause without evidence. When uncertainty remains, convert it into a targeted check, small instrumentation step, or focus test. This was something I definitely evolved as I was working with the model, and that was I might observe what an issue was, like something wasn't what I expected, but I didn't, unless I had actually looked at the code and knew exactly what the bug was. There was a bit of a back and forth conversation where I would say, here's the error, and maybe it would suggest what the issue was, and we'd build a test harness to test that hypothesis. And especially if there's potential for multiple possible reasons, you want to make sure you're building test harnesses that examine each of the different possibilities and either eliminate them or highlight, yes, this is definitely the issue, before you settle on the solution. Number 9, use project-specific rules over general assumptions. General programming knowledge is useful, but local project rules take priority. If the project has established conventions for interfaces, data contracts, error handling, diagnostics, or module coordination, follow those conventions unless the task explicitly changes them. This is and consistency with the application is usually more valuable than abstract elegance. This is definitely very useful when the model's been trained in a particular behavior. Like if there's a particular pattern that might be the most common pattern out there in the wild for whatever architecture that you're developing for, it might have a tendency to lean towards that. But if that doesn't match your own personal project structure or project conventions, you need to make sure that you're modifying the agent instructions so that it's told to follow the conventions. Again, you want to make sure that it's prioritizing your seeding information, like the documentation, source code, all that sort of stuff that I mentioned at the top of this. You want to make sure that it's prioritizing that over its own built-in knowledge base when the two conflict. And finally, require explicit QA before calling work complete. So after edits, perform a deliberate review against project standards, template patterns, interface contracts, and test expectations. Confirm that the final result still aligns with the established workflow and application design, and treat completion as an outcome of implementation plus validation plus review. Again, it's you just because the code it generated works at a sort of a cursory glance doesn't mean that that's the code you want to sign off on. This is where having that very regimented approach of proper testing and clear outlines of description of what the code that you're asking it to build is supposed to do, as well as those edge case scenarios of what it's supposed to do when it handles them, and making sure that the code that it gets back, you review it to both, sometimes that's just reading through the code and making sure that it does read clearly, and sometimes it's making sure that you have unit tests in place that are rerunnable, especially in a modern environment where it's easy to set up a development environment that has all those unit tests built into a script that just every time you commit changes up to the repository, it runs through all the unit tests and flags any failures, so you can catch problems as they happen and not have compounding problems sort of pile up in the background, making troubleshooting and fixing things all that much worse. Oh, and then I also asked you to do a checklist. So same sort of thing in a checklist form. Before generation, identify the authoritative project assets for the task, find an existing template, reference implementation, or an analogous feature, describe the exact scope of the requested change, note any constraints that must be remain unchanged. During generation, generate from an existing pattern, not from blank space. Keep the change limited to the current requirement. Reuse established interfaces, data shapes, naming, and error handling patterns. Avoid introducing new structural patterns unless necessary. 3. During each workflow formation, revisit templates and standards often. Compare generated code against known good source when problems recur. Correct drift quickly before it spreads into more files or workflows. After the workflow stabilizes, recheck source templates and project docs at milestones, not after every minor edit. Use milestone reviews before integration, after a feature slice, and before final acceptance. Increase review frequency again if errors or inconsistencies start repeating. For validation, use a focused test harness or target validation path. Confirm the intended workflow or feature behavior under the real scenario. Keep the harness narrow and preserve the scenario unless the scenario is part of the change. For diagnosis, separate observed facts from hypothesis, add the smallest useful instrumentation. Do not rewrite the harness or workflow just to debug unless necessary. And before completion, review the change against project standards and existing patterns. Confirm consistency with templates, interfaces, and documentation. Verify the change is still narrowly scoped. And confirm tests or harness results support the claimed outcome. So that's a practical checklist that I will put into a document and link to on this description to this video. That this is something you can just feed right into your prompt as like a system prompt for your conversation if you're dealing with the agent through like the web interface, or put it as part of your agent's documentation. This is a good sort of starting point for ensuring that the model follows good practices for doing the full development cycle. I also asked how would this differ for a general audience outside retro or strongly constrained code bases. It said for the general audience, the approach becomes less strict, less document gated, and more tolerant of exploration, but the core loop stays the same. So what stays the same is you start from existing project context, not a blank prompt. Prefer adopting known good patterns over inventing everything fresh. Validate new functionality with tests, harnesses, or runnable examples. Keep your changes scoped. Separate observed facts from guesses, and review before calling work complete. What becomes less rigid? You usually do not need to verify every language feature against a manual or internal reference. You can rely more on common framework conventions and standard library knowledge. Exact formatting, declaration order, or procedural structure rules are usually less critical unless the team has defined them. And the model can be allowed to propose cleaner abstractions or moderate refactors when the codebase supports that. In particular, you can rely more on common framework conventions and standard library knowledge. If you're developing using a stack that is a very popular stack in the modern era, you don't need to be as explicit in detail in the instructions that you put into the repository as far as here's what you need to follow. You can just say, we're developing for this stack, follow the best practices for this particular stack. What shifts from must to should? In constrained code base, templates and docs act as hard boundaries. In general code base, they are strong guides, but not always binding if the current code is inconsistent or outdated. And milestone-based alignment reviews still matter, but they are often architectural or product checks rather than syntax and platform correctness checks. So yeah, again, if you're dealing with an existing code base that has maybe been developed over quite a long time, then there may not be that consistency especially if there's been a turnover in the developers that are working on the project and there hasn't been a real rigorous attempt to make sure that there's a quality and consistency to the input code. So you might have to adapt based on the consistency of the data of the application that it's working with. But again, you have to kind of, none of these are really hard and fast rules. They're more about a mentality and an approach that you come into, plan, and adapt to your own specific situation. Testing changes meaningfully. In retro or tightly constrained systems, test hardenesses often prove low-level correctness and compatibility. In general software projects, validation usually expands to unit tests, integration tests, end-to-end flows, manual UI checks, stage verification, telemetry, and regression suites. So yeah, again, that's kind of, and the principle is the same: prove behavior, do not assume it. So my tests for this particular project were very much, I have a procedure, I'm going to run a test that calls that procedure with a bunch of different variants on the inputs and make sure that I don't get any errors or the outputs that come out are what I expect. But there is no, in this specific platform that I developed on, there's no unit testing API or infrastructure in place, so it's very rudimentary kind of unit testing. But if you are delving in a modern environment, there are tons of unit testing frameworks out there. There's lots of this stuff that's, again, the model should be trained on. You can get it to just say, this is the testing platform that we're using to do our both the unit tests, integration tests, end-to-end flows, all that sort of stuff. You can build all that in documentation and keep your templates and your examples to just what you need. That differs from what sort of the public documentation for those platforms states. And finally, more room for iteration. General application development usually allows faster prototyping, broader refactoring, and more experimentation before locking in patterns. The modern model can help compare options, generate alternatives, and support design exploration more freely. I don't know if there's anything I need to comment on that, but it's true. Okay, I'm going to skip over this. This is just rewriting the same thing, but for the general audience. I don't think I need to go into that. But I'll put a link to it so you can just look at those if you want. And then finally, I'll just end up with the 6 short principles. So the too long didn't read version of this are 6 points that I want you to kind of focus on. 1, start from the code base. You want to give the model real project context, so existing code, documentation, APIs, and conventions. 2, adapt proven patterns. Prefer extending known good components and workflows over generating new structures from scratch. 3, work in small increments. Make narrow changes, validate them, then expand only after the current slice is correct. 4, validate behavior, not just code. Use tests, local runs, staging checks, or manual flows to prove the feature actually works. 5, recheck alignment at milestones. Revisit your docs, architecture, and shared patterns early and whenever drift appears, then at major feature checkpoints once the workflow is stable. And 6, separate evidence from guesses. Treat observations, hypotheses, and fixes as different things. Do not claim certainty without verification. Okay, I hope you find that useful. Again, it's extremely powerful to use these tools in software development. It accelerates the ability of your developers exponentially, but you have to be rigorous about your approach and make sure you have good methods and are consistent with your both human efforts and instructions that you give to the agents to make sure that you don't end up into a rat's nest of code, I guess. Thanks for watching, and I will see you next time. Bye-bye.